Any questions for me on lab work 6? Nothing? Yes? No problem. Take your time. Great question. So, number 3 and number 6. Here, let me do this way. So number 3 and number 6 is kind of the same thing, okay? However, what I mean by that is this. If you have that, right? So are you stuck on like where to start? Is that the case? Or where did you start? Whoa, whoa, whoa. We're talking about lab work 6, right? Lab work 5? Okay. Well, in case if you guys don't know where to start here, okay, then my question to you is, what would you do with that, right? So if you look at the whole and you're like, I don't know where to go, then what I would say is look into a smaller piece, right? We've seen this before, true? Right? We know exactly what to do with that. So do that. Does that make sense? Okay, so you're talking about lab work 5. Yeah. No problem. We'll go to lab work 5. I know this question was asked before. I don't know if it's in this class or another class, but it'd be a good review to do. You're talking about number 3, so you had, actually this was not asked, sorry. It was number 5 that was asked. So this is 3x to the 5th, y to the 6th squared, and then x to the 7th, y to the 1st, raised to the negative 3 power. Distribute. So you did that. You did that. Then you start asking yourself, what likes being on top? What likes being on bottom? Everything there likes being on top, right? The x to the negative 21st doesn't like being on top, so you bring it to the bottom. The y to the negative 3 doesn't like being on the top, so you bring it to the bottom, right? So you got to there. Okay. So, go ahead. Okay. Well, it's not 9x though. It's just 9. Okay. So there's 10 x's on top, 21 x's on the bottom. 10 of them are going to cancel out. So how many x's are left, and where are they? Huh? There won't be 9 left. So here, let's do a sidebar. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10x's on top, 21x's on the bottom, right? I said 10 of them cancel out. Boop, 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 right? So how many x's are left? Where? Where are the x's? On the bottom or at the top? The bottom. Awesome. So that means you have x to the 11th on the bottom. You got 12 y's on top, 3 y's on the bottom. 3 of them cancel out. How many do you have left? Yeah, no, for the y. 9. And they're going to be on top, right? So there's my answer. That's why I was saying that I don't like the subtraction rule, because when you do 10 minus 21, you get negative 11. Where does that go? Okay? So that you guys know, when if you subtract them, again, that's why I hate that rule. That's why I do the 10 on top, 21 on the bottom, 10 cancels out. Well, I got 11 left on the bottom, right? I got 12 on top, 3 on the bottom, 3 cancel out. I got 9 left on top, right? If you guys decide to use the subtracting rule, where does that negative 11 go, right? X to the negative 11 go. That always goes on top, okay? So now you go, okay, it's a negative. It doesn't like me on top, so you move it to the bottom. Hence, x to 11 is on the bottom, right? 12 minus 3 is positive 9. That, again, goes on top. So whenever you subtract those exponents, it always goes on top, that result, okay? Is that fair? That's good? Okay. Any other questions on this problem? Any other questions on log work 5 or log work 6? Okay, shoot. It should be, Okay, so question 3 and question 6 are pretty much the same. Perfect, perfect. Let me see. Oh, I see how you did it. Okay, okay, okay. That's fine too. That's fine too. Okay. So one of the things I said about question 3 was this. In case if we don't know how to do it any other way, because we're going to have to explain this, right? So if we don't know how to do it any other way, here's the thing. If we look at the whole and we go, I don't know how to do that, then let's look to more specific, right? Just a part of it. So if I show you that, would you know what to do with that? Right? You write it out twice, double distribute, correct? Do you see the same thing in 6? Yes. Right? So the very first part, you can write it out twice, double distribute it. Right? The second term, you can just distribute the 24 and 18 and then combine like terms, and you get a brand new trinomial. Right? So you do the AC method. Make sense? Number 7, your issue is the fact that, hey, no problems about missing class. That's the reason why I record these live lectures, so that you guys can actually, in case if things happen, you guys can always review it, all right? So no need to be sorry about that. I understand that life happens. All right, so on number 7, your issue is the fractions. So in exam 1, did we talk about how to get rid of fractions? Yeah. Okay. So in other words, if we were to get rid of fractions, because this is an equation, right? So if we were to get rid of fractions, you'll be fine. In fact, the problem is that you don't know how to finish it, because that's today's lesson. Okay? So how do we get rid of fractions?
So the bottom number has to be the same.
So if you get all the denominators the same, you got rid of fractions. True? So do we all remember how to get rid of fractions? So we get the denominators all the same. So you're going to bring in the sisters and saying, what's the 11 missing?
7.
Perfect. So if you do it to the bottom, you got to do it to the top. Absolutely. Does that make sense?
Yeah.
Okay? And then once the denominators are all the same, you can go whoop, and then the top is your equation. Is that fair?
Yeah.
Okay? Any other questions there? And this is why you want to listen to the video, because None of that's written down right now, right? Not even this part is written down, right? Okay. We're okay then? We're good? Okay. Any other questions? And obviously after today's lesson, at the end, if you're like, I'm still stuck on that problem, I don't know where to go, let's talk about it. Fair? Yep. Any other questions? Yes? Number 10 on lab work 6. No problem. Awesome. So number 10 is 36, x to the third minus 387, x squared plus 567x. Subyet, subbot. So the question is there a GCF? There is. So again, for some of you guys, you may need to break these down, right? So it's this. Okay? These numbers are bigger and they're not even. Crap. Right? So let's go to the side. 387 is not even. So what should I try? What's the next prime number we know? After 2. 3. Is it divisible by 3? Oh, wait a minute. What's 3 plus 8? Plus 7. Is 18 divisible by 3? Yes. And how many times does it go into it? Huh? 60? Oh, 66? No. No. If 18 is divisible by 3, then 387 is divisible by 3. And how many times is it? 129. Does 3 go into that? 1 plus 2 plus 9 is 12, so yes. How many times? Huh? 43. Anything else go into that? Because 4 plus 3 is 7, so it's not divisible by 3. Crap. Not 4, because it's not even. Not 5, because it doesn't end with 5 or 0. Not 6, because if it's not divisible by 2 and 3, then it's not divisible by 6. Does 7 go into it? No. 8, no. 9, no. Uh-oh, we're done. Okay. 3 times 3 times 43. And then x and x. All right. Now let's look at 567. Does 3 go into that? Yeah. How many times? 189. Again, 5 plus 6 plus 7 is 18 as well. So that's why I know. 1 plus 8 plus 9 is 18 as well. So 3 does go into that. How many times? 63. Is that what, right? 63? So 3 goes into that as well. How many times? 21. 3 goes into that as well. 7 times, right? So this is going to be 3 times 3 times 3 times 3 times 7. And then x. So let's see what's in common. See where my GCFs are? forgot a circle here. What's 3 times 3 times 7? 42? Oh, no, it's not. It's not 42. What is it? 63? It was 9 times 7, really. Okay? So again, some of you guys need the primes to do it. It's okay. But you got to be willing to do it. Right? Now, some of you guys might go, let's try just 3. Well, x to the third, x squared, x. So clearly an x can come out. And some of you guys might start with a 3. Right? And then you get something, and you're like, oh, crap, there's still another one. So you might go, okay, let's do another 3. Does that make sense? Because, again, you're not wrong, you're just not right yet. Right? Okay? Okay, so now from here, you do the AC method. So what's A times C? That's not a number. What is it? 252. And my B is equal to negative 43. So how do I find those two numbers? You're going to just start stabbing at your calculator? Those two numbers have to be positive or negative. They both have to be negative, right? So would a table help here? So let's find the factors of 252. Negative 1, negative 252. They both have to be negative. If I do negative 2, it'll be what? Negative 126, still even. So those are negative 4, 63. Uh-oh. That stops. Because I can't double that, right? Because 63 is not even. Let's try negative 3. What's negative 3? Huh? 84. Negative 84. Let's double that. Negative 6. 42. If we double that, negative 12. That'd be negative 21. Is that right? Uh-oh. What happened? Well, here's the thing. What are we looking for? We're looking for negative 43, right? This right here gives me what? Negative 48. This right here gives me what? Negative 33. So that means negative 43 is in here somewhere. Does that make sense? Is it closer to 48 or 33? To 48. So if it's closer to 48, then I'm going to start here and say, okay, let me try negative 7, negative 8, negative 9. Is that fair? So what does negative 7 give me? Is it going evenly? Or is it decimal? Okay. So 252 divided by 7. No good. So let's do 8. Evenly? Is that right? No, that's negative 40, right? Does negative 9 go into it? Yes. Okay, I want 252. Does 8 go into it? No. How about 9? I know 9 goes into it. How did I know that 9 goes into it? What is it, 28? How did I know 9 goes into it? Four, 2 plus 5 plus 2 is 9. So did I do something wrong? Because this is what? 37. That's 10, 11, 12. Uh-oh. Houston, we have a problem. I'm not able to find those two numbers, right? Let's see. Number 10. You guys saw that, right? So would the negative 7 actually go into it evenly? Everybody try it. 252 divided by negative 7. So notice that I just used chat, and chat gave me wrong answers, right? This is why we got to double check it. Did it actually work? So negative 7 actually worked. And it was what? Negative? It was negative 36? Okay. So anytime we have big numbers, we should make tables. Now, does anybody not understand how to make the table? Are we okay with making the table? Yes? Yes? Okay. So no questions about that. Does it make sense that we have to troubleshoot here? Of saying, okay, let's go in between somewhere. Are we okay with that? Yes? Okay. So what do I do with those two numbers? What's step 2 in AC method? I plug it in. I split the middle term, right? Does that make sense? Try to finish it. Go. Because at least that way you guys got number 10 done. Keep on going. You're fine. I want to see it. We got 4 terms. So what's step 3? That's not what you do. Go back in your notes, look at what step 2 is and how I did step 2. What's the GCF? Oh. They're both negative. Oh, yeah. That's why you're like, I'm confused. Why does the parentheses look alike? Okay. So your goal is to make the other one look the same, right? So some of you guys have step 2 down. There you go. Yep, you're just ignoring this until the end. So you're just looking at that to split the middle. Okay. So, yeah, that's right. There you go. What's a GCF? Splitting the middle term. Look at all of these that we've done.
Right.
We keep the first, we keep the last, we split the middle. Right? The 10 became that.
Oh, yeah, 43.
That was what we've been looking for, right? What two right numbers to put in for negative 43, right? So that's what we're trying to do. You need some guide? So remember right here, once we found these two numbers, we're splitting that into the 2. And then we draw the line in the middle.
Which one is the middle term?
So there's only 1, 2, 3. So because beforehand, when we did one with a GCF, over here, did you copy down how we did it the second time? No, you didn't. So the second time we did it, we had the 8 out first, right? We did the GCF of that, and then we drew an arrow to the bottom. So that's the one that you didn't copy down. You would have copied that one. You would have had that. So what's the GCF of the first group?
It's in this order.
Doesn't matter which order it is. As long as it's the 4x minus 7 and the x minus 9, it doesn't matter which way. Because, again, each parenthesis is just a number. So 2 times 3 and 3 times 2 equals the same thing, right? The shy girl.
I still don't know.
So look over here. So over here, remember we had 3 terms, right? Once we found these two numbers, we split the middle term. So there's the one in the middle that we split into 2, right?
So we're still bringing these down.
Yep. So the first and the third stays. The one in the middle splits them apart.
Which are these numbers?
Yeah. Because that's what we've been looking for, right? So which one's in the middle? And you forgot the x in here. The 43, right? So that's the one that gets split. So you keep that, but the middle gets split in half. Well, into those two numbers. What's the GCF there? If you have the right primes, do it. All right? And then whatever the parentheses is, you want the same thing here. So what do you got to pull out of here to make the same parentheses? Why is it plus? That says a minus right there, right? That doesn't make sense at all. So one of the things I did in one of the problems when we had a GCF was that we just drew an arrow for this 9x, and then we did this, right? We put it out of sight. Step 2 says to take the results in step 1 and split the middle term. Okay? So here's the thing, guys. These are the 3 steps that, for most of you guys, are going to be the hardest 3 steps to remember. Why? I'm not sure. But it carries on in real life as well. So let's say, for example, that wherever you're working, you got promoted to be a manager. Okay? Worse yet, you're the closing manager. Do you guys know what a closing manager needs to do? So a closing manager typically has a list of things that needs to get done, right? And when you start, they usually give you a list so you can check it, right? And when you first start that, what happens? You got to go back to the list over and over, right? Okay, yep, I got to go get that done, check. Oh, I got to go get that done, check. Oh, I got to go get that done, check. You can't remember it. Like on the first week of doing it, you can't remember it. You got to keep on going back to the list. But after a month, what happens? I don't need a freaking list anymore. I know exactly what needs to be done. Does that make sense? Because you keep on trying to get the stuff on the checklist done without looking at the sheet, and then come to the sheet and make sure, okay, I did. Oh, that's where I forgot. Right? And next week, you get more of the sheet done, and you might forget now 1 or 2. After a month, you don't need the list anymore. Next person that gets promoted to a night shift, you're saying they're a poor kid. You got a lot to do. Make sense? This is the same thing, except this list only has 3 things. So the only way to remember those 3 is do a problem and going, okay, I'm getting step 1 done. I'm stuck on step 2. Chan, I need help. All right, let's go through that bump. Now you know, okay, I got step 1, step 2 down. Step 3, I need some help. Get that bump. So the first 10 or 20 problems, you might have to have those 3 steps right next to you to go over, and again. By about the 30th problem, you're like, huh, I remember the 3 steps, right? At about 25, you're like, what was that 3rd step again? Oh, that's right. In class, he said, look at how many terms we have. We have 4 terms. What do we do? Oh, we got to group them. Got it, right? Now when you get to the review, you can go, okay, let's try to do it without any notes. How do I do, right? So that is the part that you guys need to make sure that you get into. So we keep the first term. We split the middle term. With the results in step 1, which was negative 7x minus 36x plus 63. 3rd step, split the middle. GCF of the first group is just x, leaving me with. I know that the second parentheses needs to be the same. And the 3rd term is a negative, so I know I got to pull a negative, but negative what? So 4 times what gives you 36? 9. So double check it. Say, that gives me negative 36. Awesome. Does that give me a positive 63? Yes. Awesome. I got it. Now I got 4x minus 7 and x minus 9. You bring it down. There's my answer. Nothing. Doesn't matter if it's a perfect square, it's just a GCF. Okay. Now, if we see square terms in these x's, then we might want to look at it because these are two terms, right? And we went through step 2 about two terms. So if there is a perfect square in here, then we might want to look at it, right? Yeah, 9 is a perfect square, but x is not a perfect square. So, yeah, but the problem is that there's not two terms. It's not subtraction, right? So again, so here's the thing, guys. So just so you guys understand, in high school, from when I was in high school, when I was learning this, we had no AC method. The cool thing about AC method is that it works every single time. Okay? If I do not find these two numbers, then I know my trinomial is not factorable. I got to stop there after the GCF. Okay? Then this right here on top with the 9x, wait for it, that would be my answer. Okay? If I couldn't find those two numbers. Okay? But you have your calculator in front of you, so we found those two numbers. So in high school, we had something called trial and error. And that's why we learned FOIL, because that is synonymous with trial and error. So the teacher's idea of us getting it down, we essentially for 3 weeks, we had like 50 problems a night. And we didn't have block scheduling, so it wasn't like every other day. It was like every single day you had math. So it was like 50 problems a night, every night. Okay? The problem is that the ones that don't understand trial and error couldn't get it. Teacher's idea was 50 more problems. The problem I have with how we're teaching it right now is the fact that you guys don't get enough practice. You don't. So you literally need to go, I need more practice. So there's no shame in going, not the settings. No, not picture, duh. There you go. And practice that. Does that make sense? I'm telling you guys right now, your exam is next week. Review is already open. We got to get it down. We got to get the factoring down. Now, is there a way around Interesting. You don't need to do step 3. There's a way around it where you can get a decent grade on exam 2. The problem is that if you don't get this down, exam 3 is going to be atrocious. Absolutely atrocious. And your spring break is going to be atrocious because you're just going to be thinking about how am I going to raise this grade. I always try to plan on having majority of exams done before the add drop date, which is, I think, right after spring break. Or right before, one or the other. Can't remember which one. Because the date gets all screwed up. Right? So you guys need to get these 3 steps down. Out of this whole course, this is probably the most important thing for you guys. All right? I'm forewarning you right now, okay? There's a way of still clearing exam 2 with a decent grade. Exam 3, however, do you know why exam 3 becomes like really critical? Do we all understand this? No? Okay. So let me explain to you. So right now, each problem we might have to factor once. Okay? Exam 3 is about adding, subtracting, multiplying, dividing fractions. A fraction has a top and a bottom. If we add fractions, there's another top and bottom. So that means there's 4 pieces. Agreed? No matter what we add, subtract, multiply, divide, there's going to be 2 tops, 2 bottoms. However, we're putting everything we're currently learning into those fractions. So you might have to, each problem, you might have to factor 4 times. So you might have to run the AC method in your head 4 times. But if you get it down, I'll tell you the easy way and when to use it, then the AC method is maybe twice rather than 4 times. Does that make sense? That's why I'm saying in this exam, there's a way around it. But when you get to exam 3, there's 0 ways around it. You either know the AC method or not. And if not, that's why it'll be atrocious for that reason. So it means that you're going to have to put in the time, do 30 to 50 problems or more, so you got those 3 steps down. Now, one of the things I used to say, I want you to practice enough, and I said this to you guys before, I believe, that you're willing to bring your $1,000 in, put it on the table, and saying, give me a problem to factor, I got it. If you factor it correctly, you get the money back. If you don't factor it correctly, I put it in my pocket. Do enough problems that you are willing to make that bet. Is that fair? If you're like, I'm not sure, you're holding on to the $1,000 while you're doing the problem because you don't want to let it go, that means you didn't practice enough. Okay? All right. Any other questions? So we're ready for today's notes. All right. Today, we're going to learn about quadratic equations. And guys, don't forget, you guys made yourselves some promises after exam 1, didn't you? You answered 4 questions. Question 1, how much time you spent? Question 2, what materials did you use? Question 3, what grade did you think you got? Question 4, now that you know your grade, how would you change the answer to questions 1 and 2 to better your exam 2 grade? Okay? So you made some promises to yourself. So the question is, have you kept that promise yet? Bless you. Okay? All right, so quadratic equation. So am I correct by saying that you guys saw this right here being written at some point? Yes? Is this in your notes somewhere? The only difference of what we've learned so far and this is this. Ready? Ready? That's the only difference. There's an equal 0. There's an equal 0. That's the only difference. There's an equal 0. Right? All right, so you're going to hear these words a lot. If I see a square term and an equal sign, we think of quadratic equations. If you see a square term and an equal sign, think quadratic equations. If we see a square term, equal sign, think quadratic equations. What the heck is a quadratic equation? So let's look at that equation right there. What do you notice is on the right side? What's on the right side of that equation? 0. So for a quadratic equation means we have to have a 0 side. What's on the left side? Is it 0? So when we see a square term and an equal sign, we think quadratic equation, which means we have to have a non-zero side and a 0 side. Meaning getting everything to one side so that one side is equal to 0. Okay? So every time we see a square term, an equal sign, we think quadratic equations, move everything to one side so that we have a 0 side and a non-zero side. And we factor the non-zero side. Don't factor the 0 side. Not much work to be done because it's 0. Is that fair? Pretty easy? All right. So let's jump into an example. What do I see? We see a square term and an equal sign. So what are we thinking of? Quadratic equation, which means we got to do what? Bring everything to one side. So the largest term here is the x squared, right? Or the largest power term is the x squared. Do we ever want x squared to be negative? No. We always want the x squared term to be positive. So we never want to move the 12x squared to the right side and make it negative. We always want to keep that x squared term positive. Because all the factoring that we've done, the x squared term has never been negative. Is that true? Okay. So I want the x squared term to be positive. So I'm going to keep the 12x squared right here. I'm going to move the other 2 over. So plus 5x minus 72 is equal to 0. Questions? Well, how do I bring something over to the other side? Right? Because I got to get rid of it from the other side, so I got to, right? So everybody got step 1 down? See a square term, equal sign, quadratic equation. Bring everything to one side so the x squared term is positive. Step 2, we have to factor the non-zero side. What's step 1 in factoring? It was from last week. GCF. Is there a GCF? Huh? No. No. How many terms are there? So what method do we use? The AC method. Okay. What's A times C? Negative 864. Someone double check that for me. And the B is positive 5. Uh-oh, I gotta find those two numbers. Oh no, oh no. What should I make? A table. Tell me about the numbers. Is it this way? Is a bigger number negative? Are we sure? Or is it this way? You think it's that way? Why? So if we multiply together, it has to be negative. So that means one number has to be negative, one has to be positive, right? Because both methods that I just used, they both multiply together to give you a negative number, yes? But we have to add together to get what kind of number? Positive 5. So which number is going to be negative, which number has to be positive? The bigger one has to be positive, right? And the smaller one has to be negative. Does that make sense? So look at it. If I multiply these together, do I get negative? Yes. If I add these together, is it positive? Yes. Right? So now I have a key. That's the reason why I write this first one down. It's just as a key, so I know, remember, smaller number has to be negative, larger number has to be positive, because I multiply together to give you negative, add together to give you positive. Okay? So I'm going to start. Negative 2. 432. Negative 4. 216. Negative 8. 108. Negative 16. 54. Negative 32. 27. Uh-oh. Is that right? Should I use negative 32 and positive 27? Yeah? Didn't we say the larger number has to be positive? So my two numbers are now you're going to go, wait a minute, why do you write the negative number first and the positive number second? Why didn't you write exactly what was written there, 32 and negative 27? Great question, isn't it? Which one that you guys should have asked, right? I was about to. Okay. So what's the next step? So how about this? Since some of us are stuck in step 2, let's have everybody write down what the next step should look like. What that next line should look like. Go. Because I want to make sure that everybody got step 2 down. Because when I went through the previous problem, step 2 was where we got stuck, right? So write down what the next line should look like. Don't forget your x's. What should the next line look like? That's not what the next line should. Oh, wait a minute. You got that next line. You got it. Okay. Good. What's the next line should look like? So, undo. So, when you find these two numbers, where did those go? And you should erase this. Where does those two numbers go?
Negative 364 goes first.
No. This is what we're looking for in step 1. Those two numbers. Where did those two numbers go? Go back to last notes. Keep on going. See those two numbers? Don't you see it right there? Because we took this number in the middle and split it with those two numbers. This stayed the same. That should be a square right there. And the 160 stays. So these two numbers stays. It's these two in the middle that is where those are. Look over here. Same thing. 3x, that's supposed to be 3x squared. That's supposed to be that right there. The negative 10 became these two numbers. Where did these two numbers come from? Came from right there.
Okay.
Make sense? So write that next line. Thank you. Or don't write it down. Awesome. We're okay? No, you got it. You got it as well. Awesome. Did you get it already? What do we do with those two numbers?
These?
Yeah.
32 and 27.
Yeah, where did they go? Where? That's why I want the next line. When you plug it in, where does it go? No. So when we found the two numbers here, you didn't copy half of the things down. Now I know why you're confused. So you did the A, you did the C, you got these two numbers here. No, that's not even the right two numbers. Okay. See how you got the negative 5, negative 4? That splits into those two. This stays and this stays. So none of those notes are complete. So that's why you have no idea which one, where it goes. I can't show it to you here because you don't have anything copied down. I can't show it to you here because you got the wrong things copied down. And I can't show you here because you didn't do it either. And then you didn't copy the problem that was written, which is number 10, which is part of your lab work. Okay. Do we get it? I would just care about that. Okay, cool. All right. So again, I'm using the results here to split this term. So that means I got 12x squared minus 27x plus 32x minus 72 equal to 0. Now, the reason why I'm writing the negative first is because then I don't need to pull a negative out of that second group. Does that make sense? Does it matter if you put the 32 first and the negative 27 second? It does not matter. We still get to the same answer. The only thing is that if you put the negative 27 second, that means it's a third term. You have to pull a negative out of the second group. Okay? That's the only difference. That's the only reason. If I have a choice, I'm going to write the negative first to avoid that remembering to pull a negative out of the second group. That's it. Okay? So here, you guys might need to do some recon, right? Gaussing bot. Do we see where the 4x came from? Do we see where the 9 came from? 3 times 3. Oh. Oh, shoot. I know, yeah. I see why I did wrong. Because these are supposed to be 2s, right? There we go. Are we okay there? Well, again, third term is negative, so you should pull a negative out of this.
Yeah, there's a negative sign here.
Then why did that stay as plus 8? Oh, you know what? No, you're copying error. This was minus 72. And then you made it plus. See what I'm saying?
Yeah.
That's all. So this would be right. So it's 3x plus 8, which you got, and then the 4x minus 9, which is there as well. But
I just think
this is wrong.
here, but there's a negative 9 here.
Yes, but why I'm saying it, this is supposed to be, because there's no way this can turn positive with this negative if this wasn't negative. Make sense? Okay. So are we clear with step 2 now? So step 3, again, if we need factor tree, let's do it. But do we understand what I did here compared to what I got here? That is the bigger question, right? Because if we don't understand what I'm highlighting or what I'm circling in terms of where everything is, then we're going to have some issues. Okay? So typically, if it was last class, we would be done. So what is the next step? What does that equals 0 make us do? Okay? So here it is. Ready? I said each parenthesis is just a number. So this says a number times a number equals 0. When are the only times that I multiply two numbers, bless you, would equal to 0? So if I do 0 times a number, it'd be 0. A number times 0 would be 0. Or 0 times 0 equals 0. True? So all we do next is this. We say, okay, so that means 4x minus 9 could be 0. And 3x plus 8 could be 0. Right? Because if it's 0 times anything, it'd be 0. Or anything times 0 will be 0. Or 0 times 0 equals 0. So we take each factor and set it equal to 0, and then we solve. And you're wondering, how the heck did I get that? Is that why you're wondering? Let me ask you this. How do you get x by itself? Okay. And then what? How change what? It's the same exact thing, right? Because if I move the 8 and I divide by 3, right? Okay, that makes a circle. What the? Questions? What did I say to you last week? Everything that we're learning going forward, we got to know how to go backwards with. If you're given this answer, can we get back to the original problem? Here's the thing. What if we follow the steps? If we're given this, you can write that. Yes? Awesome. If you can write that, question is, can we get back to here? What did I do going from here to here? Divided, right? So what's the opposite of dividing? Multiply by the denominator. So the left one I multiply by 4 on both sides when I get 4x equals 9. And then subtract the 9 over. Get it all to one side, right? Now a binomial and a binomial. I multiply those two binomials. Double distribute. Voila. I get back to this right here. Make sense? So again, from here to here, I had to divide by 4. Opposite of that would be multiply by 4. So that these cancels out. So I'm left with that. And then from here to here, I had to add 9. So now from here to here, I subtract 9. So I get that. Do the same thing over here. Now that I have that, double distribute. I get this. And then combine like terms, I get back to that. Now, are you ever going to get back to this? No, because we don't know what they want. But all it's going to ask for is to get there. Okay? Questions? None? Nothing whatsoever. All right. I want to talk to you guys the difference of these two problems here. What's the difference between these two problems? One equals 0 and the other one equals 14. So the one on the left is saying, hey, I have two numbers multiplied together to give you 0. I know that 0 times anything is 0, anything times 0 is 0, and 0 times 0 is 0. So the one on the left is really easy. The one on the right, can I say anything times 14 equals 14? No. Can I say 14 times anything equals 14? Can I say 14 times 14 equals 14? Definitely not, right? Does that make sense? Everybody clear on that? So, in other words, I can't do the left problem the same I would do as the right problem. Not okay. The one on the left, since it's already equal to 0, and it looks very much like what we just did right here. Right? It looks exactly like this. Same layout. So the one on the left is very easy because all we got to do is say, okay, x plus 2 equals 0. 2x minus 7 equals 0. So x equals negative 2. X equals 7 halves. Done. Are we okay with that? And the reason why we can do that one on the left is because 0 times anything is 0. Anything times 0 is 0. 0 times 0 is 0. The one on the right, we cannot do that. So if we can't do that on the right, what are we going to do? How will we do the one on the right? I got to take one step back so I can go forward. Okay? It's kind of like me trying to get out the door. I'm here. Right? I can't go forward unless I take a step back and go out. So, yes, I will have to double distribute this. Go ahead and do that, guys. Of course, you guys are going to show the double distributing, right? You're actually going to show the double distributing, right? At least on the lab work. Huh?
I just FOIL it.
The reason why I double distribute is because when we're going backwards, we see the double distributing. You don't see the foiling, right? That's why.
I feel like it's easier for me to do this.
I don't disagree with you. I don't disagree with you whatsoever. But what I'm saying is that when you're going backwards, you're not going to see that step. Because if you go from here to here, you can't go from here to here. Now, if you know how to factor through trial and error, I would agree with you. Let's do that. Combine like terms. What am I going to say? I see a square term and an equal sign. I should be thinking quadratic equations, which means I got to get everything to one side. Now I have the equal 0. Now I have a new trinomial. Now I have to use the AC method. What's A times C? B is 3. What are the two numbers? Does that work? Write that next line for me then. I want to see that next line. Show me that next line. I want to see it. I want to see that we all got step 2 down. No pressure. Oh, geez, Louise. Yeah. Oh, this is over here. I was like, what? You didn't write the problem down? What? Let's make sure that we all have step. You want going? No. So we're just splitting this with these two. So you got negative 3x plus 6x minus 18. Okay.
Equals 0.
Equals 0. So notice over here, these all stay. Just this could change with that. See what I'm saying? Because, and here's the thing, I keep on making marks. Because this right here still equals that.
Okay.
Right? Because if I add those two numbers together, I get that. Right? What we're trying to do is make 3 terms go to 4 terms.
Okay.
Once we got 4 terms, we go, oh, it's 4 terms, so I got to split it down the middle and do grouping. Yay! You're supposed to use these two numbers to split that term. So you got to use both of these in here. Not like this. The last goes last, the first goes first.
Skip that.
Yeah, you can't skip that. You have to get it.
Okay, so it's
Because remember we said we got to get the square term and the equal sign. We think quadratics, we got to bring everything to one side. So bringing this
Okay.
over, we got to
So this
subtract
would be
4.
18.
Yes.
Okay.
Yeah. Does that make sense? We're okay? So, again, the first term stays first term. The last term stays last term.
So, there.
Then we take these two numbers and put it in the middle.
Okay, so I just had them placed wrong.
Mm-hmm.
Like that.
Don't forget the x's. Because if I add these like terms together, it'll give me that back. So in other words, this and this are equal to each other. They're the same. Okay? Oh, don't forget the x. Yep. Nice. All right. Slowly getting step 2 down. Now that we have 4 terms, GC of the first group, we know that the second parenthesis has to look the same. So what do I pull out? Or better yet, 6 times, oh well, what times x would give me 6x? And you're going to tell me 6. So let's double check. 6 times x gives me 6x. 6 times negative 3 gives me negative 18. Check. Awesome. Questions? Do you guys see how the one on the left is so different from the one on the right? Right? Just making that right side a number throws a wrench in the whole thing. All screwed up. We got to try to fix it. The one on the left is like perfectly fine, easy peasy. Right? Right? Kind of like going to the DMV. Some people that go up, boom, boom, done. Or heck, just a self-checkout line. Right? It's always funny to me when people go pay for food, or when they go pay for groceries, they forget that they're paying, so they're like, oh, let me get my wallet now. What? You know you're paying, so why isn't your credit card already out or your cash already out? Or like people go into Sam's Club or Costco, they're like, they get to the door, they're like, oh, let me get my card out. They look at your card every single time. So why are you waiting to the door and then jamming everybody up so that you can find your membership card? Like, this doesn't make sense to me. Right? Or some people at a self-checkout line is like, doop. They're done scanning, they're done paying, and now they're bagging everything and putting in the cart. It's like, dude, couldn't you have bagged while you're scanning? Wouldn't that make more sense? Because I know when I go shopping, I already know what's going to which bag. Soft stuff, hard stuff, where it goes in the cart so that the hard stuff doesn't crush the soft stuff, right? That makes sense to me. But I understand that not everybody is me. And I'm sure that there's some people that look at me going, what's taking him so long? Right? So I understand that too. Questions? So again, I ask you, does that help you with number 7? Huh? Well, because you already asked number 7. So does it help you with number 7? Or what number 7 was? Okay. Take a look at it. See if it helps you with number 7. Yes, no? Because you got rid of the fractions. Okay, so if you got rid of the fractions, you'll only have a regular trinomial left, right? So then, right? It would be like something like this. Oh, sorry, something like this, right? Except it's going to be 3 in front, and then you do the same thing. Okay? And then set equal to 0, and that's your answer. No questions? Any questions on the review? I'm sure everybody opened the review already, right? Let's see. I actually don't know when I opened. Maybe I didn't open it. Let's see. Hey. You're trying to think of what time you opened it, right? Try to open it, right? Was it after 6 p.m.? Oh, okay. So for you guys, it's always a week and a day before, or a week and a night before. So there's always that Tuesday night a week before. for the exam. And don't forget, people who are taking it at home or taking it online, you're supposed to be sending me a message if you're taking it online or not. If I don't get a message, that means you're staying right here. You're coming to class and take it. And don't forget that your setup needs to be better if we talked about it. So no questions on the review? Lab work. Number 6 on the lab work. So same. So the question has already been asked, but let's talk about it, because if not, we're going to keep on asking the same question. All right, so you're looking at it as a whole, and you're like, I don't know what to do. Is that right? Is there anything in there that looks familiar to you? Is there anything in here that looks familiar to you? Anybody can answer. So that looks familiar, is that right? What do we do with that? Write it twice, double distribute, right? But don't multiply the 6 yet. You got to double distribute and then distribute the 6 through. Does that make sense? Yes, no? Okay. We know what to do there? Just distribute, right? Distribute the 24 in. True? Once you do that, you're going to have a bunch of like terms. You're going to combine those like terms. You'll have another trinomial, and then you'll factor that. Are we okay? So the first one, you're going to have something like this. I'll get you guys part ways here. But you guys got to show this work here. You're going to have something like that. So the 6 got to get distributed, 24 got to get distributed, and then you combine like terms. Is that fair? Same thing with number 3. Oh, you did that in number 3. So why would it change with number 6? You thought there was going to be an easier way. Oh, you did do that.
No, I did do that, but it just, I didn't do the other steps.
Ah.
I thought that was the answer.
Gotcha. Well, you know what? Well, you got to factor it. A times C.
Yeah, that's the thing.
So you're in the right track then. Make sense? You're in a good place. You just gotta, because remember the direction says factor the polynomial completely, right? So you're good. You just gotta finish. First term times that, second term times that. Any other questions? Yes? You will see it. Because when you double distribute, you're supposed to do this, right? Which means that this right here take the first term, distribute it through, right? Take the second term, distribute it through. Right? So you'll see the 2a, 2a, 2 times 2. Okay? I understand exactly what you're saying. You're like, I see, but not seeing what's in between. That's all. Yep. It's the middle. Where did that come from? That's why I was like, I want to put it down so that you can go through the process and you go, now I know where that 4 came from. Any other questions? This is what I'm going to do. I'm going to drop the mic. I'm going to let you guys see if there's any other questions. When I come back from the little boys' room, hopefully that you guys have questions. You might want to open up the review. Just saying. Questions? Yes? Sure. Sure. Number 10 on the review. Ah. That's the question I was looking for. So it gives you the solution. And it wants you to find a quadratic equation. So I got to go backwards. So you agree with me that I can write it this way? Okay? Okay. So let's just deal with one. Let's not try to deal with both at the same time. Let's just deal with one. How do I get everything to one side? You could do x minus 5/3 if you want to, but then you got to FOIL that with a bunch of fractions, which nobody wants. So how do I get rid of the 3? Ooh, you guys could. Oh, I love that what you just said. So the other thing to think about is, let's say you had no idea where to go. We talked about if we get the fractions, if we get the denominator the same, then the denominator goes away, right? Because it is an equation. So I can say the 1 is missing a 3. If I do it to the bottom, I have to do it to the top. Now you see that my denominator is the same. Agreed? So now I have 3x equals 5. So what do I do with the 5? Are we okay? Let's deal with this one. What's the 1 missing? If I do it to the bottom, I got a. Awesome. The denominator is the same. Agreed? What do I do now? Take the first term, second parentheses, second term, make sense? And then finish. Once you finish, yeah. You had a question as well. It's okay. Oh, do you have a problem on the review? Which one? Number 7? Sure. Cảm sập gaya chat. That should be your answer there. Number 7. Okay? Let's just look at just this right here. What is the power of 0 attached to? Awesome. So if the parentheses raised to the 0 power, what is the parentheses equal to? What's anything raised to the 0 power? What is the power of 0 attached to? So that means the 8 is not affected. What is x to the 0 power? Now, all the words I've been saying, are they the same words I keep on repeating? Right? I don't like, it's not like I'm talking a different way. It's always the same thing. Right? What is the power attached to? What is that equal to? Yeah, do what you gotta do. See me judging right now? So much judging. So angry. I'm so angry. So you see this anger right here now? Super angry. You too. Any other questions? Nothing? That's it?
Is the answer for question number 25?
Yes. Because what was the power attached to? The parentheses. Right? What's the parentheses raised to the 0 power? 1. So no other questions. That's it. Nothing at all. Yep. It doesn't matter. Remember, if you guys go back to the video, I actually said to you guys, doesn't matter what's inside the parentheses. No. You can put a ton of things in the parentheses. If the parentheses being raised to 0, that parentheses is all 1. Pretty sure I said it here in the notes. If you guys watched the video. Any other questions? I know that you guys all have other classes. You're not just taking my class. I understand that. But I will also say to you that if I were in your seats, this is what I would do. If we're stuck in factoring, if we're stuck in step 2 and step 3, I would review those videos. In fact, I would refer back to the videos in week 5 and week 6, meaning 4 videos. Because there's 2 in week 5, there's 2 in week 6. I will review those 4 videos and play back in that step 2. Play back to step 2. Play back to step 2 until you get it. You might want to get an example problem, right? A problem that is a trinomial, right? You can tell ChatGPT to say, hey, give me a similar problem. And go, okay, let me go through the AC method again. Once you see what happened, pause, do it, put it again. Or even in the video, if you wanted to, when I start a problem, right, that we've already done, go, okay, let me try step 1. Play it. See if you got it right. Pause, try to do step 2. Play it, see if I got it right. Pause, do step 3. Play it, see if I got it right. Right? Then you can take a picture of it, give me a similar problem, try to go through it. You can always check your answer by double distributing in to see if you get the same trinomial again. Now you're practicing multiplying binomials, right? You're still practicing. The cool thing about going forwards and going backwards is that you're practicing both directions, because we learned both directions, right? So again, yes, you have other things that you got to get done, but if you have the time, if I were you, I would go back. Yes?
We're able to take the review as many times over, correct?
Yes. Yes. I would tell you, though, the first time, take it with no notes. First time taking the quiz, take it with no notes. Then print the PDF out, compare the problem, make sure it's the same problems that you got right or you got wrong, especially the ones you got wrong, and mark those off on the PDF, on the printout. So they go, okay, I need practice on this problem. Where in the notes did he do that? And you guys can easily do that by saying, okay, let's say I go into week 5 here. You see the live lecture part. If I click on the live lecture, you see the PDF of those notes, right? And say, okay, where in the notes is it talking about that type of problem? Right? Then you can go, okay, I need to play this video. Right? If it's towards the end, I can fast forward it till that part. And now let me watch that part and let me try to understand what the heck's going on. Now let's get some problems to practice so that I can get it right next time. Is that fair? All right. This is all in your hands, but I would tell you that out of all of this, the factoring part is the most important part. The AC method is the hardest part because the factor by, if you do the AC method, you're going to practice the factor by grouping, the 4 terms, right? Always. And then work on the 2 terms because that's the only one that doesn't work on either the 4 terms nor the 3 terms. But every time you work on 3 terms, you're working on 4 terms, right? So, any other questions? Nothing. All right, ladies and gentlemen, please have a wonderful, blessed day, or wonderful, blessed weekend. Please be safe. Love you guys. See you guys next week. Later.